Welcome to the Software System Design Q&A series. In this series, we'll explore the most important system design concepts and interview questions that every software engineer and architect should understand. But system design is not just about adding more servers. How would you design a scalable web application? Start with DNS and a CDN to route users and serve static content globally. Next, use a load balancer to distribute traffic across multiple stateless application servers. Add Redis or Memcached for caching, reducing database load and improving response time. For the database, use primary and read replicas for scalability and high availability. Use object storage for files, message queues for background jobs, and monitoring for visibility and alerts. The key principles are simple: scale horizontally, cache aggressively, replicate data, process asynchronously, and design for failure. That's the foundation of a highly scalable and reliable web application. How do you handle millions of concurrent users? The key is to distribute the load and remove bottlenecks. Start with DNS and a CDN to route requests and serve static content globally. Use a load balancer to distribute traffic across multiple stateless application servers. As traffic grows, simply add more servers. Add Redis or Memcached to cache frequently accessed data and reduce database load. For database scaling, use read replicas, sharding, and proper indexing. Move heavy operations to a message queue, where background workers process them asynchronously. Finally, use auto-scaling, monitoring, rate limiting, and security controls to handle traffic spikes and failures. The rule of thumb: distribute the load, eliminate single points of failure, cache aggressively, process asynchronously, and scale horizontally. What is the difference between horizontal and vertical scaling? Horizontal scaling means adding more servers. A load balancer distributes traffic across multiple machines, allowing you to scale up or down based on demand. Its advantages include high scalability, better fault tolerance, and minimal downtime. The trade-off is increased system complexity. Vertical scaling means increasing the power of a single server, such as adding more CPU, RAM, storage, or bandwidth. It's simpler to implement, but hardware has limits, costs can increase quickly, and the server can become a single point of failure. So, the rule of thumb is: start vertically for simplicity, then move to horizontal scaling when you hit hardware limits or need high availability. What is load balancing? Load balancing distributes incoming traffic across multiple servers to improve performance, reliability, and availability. Here's how it works. Users send requests through the internet to the load balancer. It then selects the best healthy server to handle each request and returns the response to the user. Common algorithms include round-robin, weighted round-robin, least connections, IP hash, and random. The major benefits are better performance, high availability, scalability, and fault tolerance. So, the rule of thumb is: distribute traffic, maximize resource usage, and keep your application fast and reliable. What is caching, and where would you use it? Caching means storing frequently accessed data in a fast storage layer, so future requests can be served much faster. Instead of querying the database every time, the application first checks the cache. If there's a cache hit, the data is returned immediately. If there's a cache miss, the application fetches the data from the database and stores it in the cache for next time. Caching can be used in the browser, CDN, application or API layer, database query results, and user sessions. Popular technologies include Redis, Memcached, and Amazon Elasticache. The key benefits are lower latency, reduced database load, better scalability, and improved performance. Remember, cache frequently, invalidate carefully, and monitor your cache continuously. What is a CDN, or Content Delivery Network? A CDN is a distributed network of servers that delivers content from locations closer to users, reducing latency and improving performance. Here's how it works. When a user makes a request, it's routed to the nearest edge server. If the content is already cached, it's delivered immediately. If not, the CDN fetches it from the origin server, caches it at the edge, and then serves it to the user. CDNs are commonly used for images, CSS, JavaScript, videos, PDFs, and other static content. The key benefits are faster performance, lower latency, high availability, scalability, and reduced bandwidth usage. So, the rule of thumb: use a CDN to deliver static content globally, improve user experience, and reduce load on your servers. How would you design a highly available system? The goal is simple: keep the system running with minimal downtime, even when components fail. Start with DNS to route users to a healthy region, and use a CDN to serve static content closer to users. Deploy multiple load balancers and distribute traffic across multiple availability zones. Keep application servers stateless, so they can scale horizontally and fail over easily. For the data layer, use a primary database with read replicas and automatic failover. Add Redis or memcached for fast access, a message queue for asynchronous processing, and object storage for files and backups. Finally, use health checks, auto-scaling, monitoring, backups, disaster recovery, and zero downtime deployments. The key takeaway: eliminate single points of failure, add redundancy, monitor everything, and always design for failover. What is fault tolerance? Fault tolerance is the ability of a system to continue operating even when one or more components fail. The key idea is simple: anticipate failures, detect them quickly, and recover automatically. For example, if one application server fails, the load balancer detects the failure and redirects traffic to healthy servers. At the database layer, replication keeps multiple copies of data. If the primary database fails, a replica can be promoted automatically. Fault tolerance is achieved through redundancy, health checks, automatic failover, data replication, backups, and distributed architecture. The result is high availability, minimal downtime, and reliable, scalable systems. Remember, design for failure, not perfection. That's the key to building reliable systems. What is redundancy? Redundancy means having duplicate components or systems, so if one fails, another can take over. Why is it important? Redundancy helps prevent single points of failure, improves availability and reliability, and enables faster recovery from failures. For example, if one application server fails, the load balancer can automatically route traffic to healthy servers. The same principle applies to databases, storage, networks, power systems, and even entire data centers. Common types include hardware redundancy, network redundancy, data redundancy, power redundancy, and geographic redundancy. The key takeaway: add redundancy so failures don't cause downtime. Remember, design for failure, not perfection. Redundancy is the foundation of highly available and resilient systems. How do you eliminate single points of failure? A single point of failure is a component whose failure can bring down the entire system. The solution is to add redundancy, distribution, and automatic failover. Instead of using one load balancer, deploy multiple load balancers. Use multiple application servers so traffic can continue if one server fails. For databases, use replication and read replicas. For caching, use a Redis cluster, and use redundant object storage for important files. Distribute infrastructure across multiple availability zones or regions, and use DNS failover to route users to healthy infrastructure. Add health checks, monitoring, backups, auto-scaling, and automated recovery to detect and handle failures quickly. The key takeaway: never depend on a single critical component. Design for failure, always have a backup plan, and keep the system available. Thank you for watching. If you found this video helpful, please like, subscribe, and share.